In today's video, we're going to be talking about robots built from nature's best-kept secret. Spot Mini robot that can lift glasses, open doors, and operate both indoor and outdoor. OctopusGripper that wraps itself around objects. CRAM, built for search and rescue missions. Snake robot that can move in almost any direction. Biohybrid Stingray that moves in only one direction. Batbot that flies just like a bat. Salto that bounces and jumps through obstacles. A salamander-like robot that is useful in search and rescue mission. And Eelume, which conducts underwater vehicle repairs and maintenance. Number 9. Spot Mini. Spot Mini is a 55-pound dog-like body with a long dinosaur-like neck and an optional snake-like arm. It is an agile and mobile robot that navigates places with outstanding mobility, allowing you to automate regular inspection jobs and capture data safely and precisely. This compact four-legged robot can move around your office, home, and even outdoors. It can sense and avoid obstacles, climb stairs, map its environment, and also open doors. The robot's mainframe has a quick disconnect battery, stereo cameras in the front, rear cameras, and side cameras. It can be upgraded with a series of attachments on its top, including an articulated arm. This arm can carry and power inspection equipment of up to 14 kilograms, lift a glass from the sink, put it in the dishwasher without breaking it, and can also fetch you a drink. Number 8. OctopusGripper. An octopus gripper is made almost entirely of soft muscles, just like the real octopus. It is a gripper with an octopus-like tentacle that is a flexible silicone structure with 2 rows of suction cups. It can be controlled pneumatically. When you apply compressed air, the tentacle curls inwards and gently wraps around the object. As soon as the tentacle has wrapped itself around the object, a vacuum is applied to the suction cups, and the OctopusGripper won't let go of that object. The tentacle is surrounded by a lycra fiber cover that restricts expansion and protects the silicone outer skin from bursting, while a wafer-thin polystyrene film is installed in the middle of the tentacle to make sure that the structure only bends inwards. The OctopusGripper is designed to work with humans in an industrial environment. The soft and flexible nature of its arms means that the gripper poses no danger to its user. Number 7. CRAM. Cockroaches are known for their hardiness and ability to disappear down cracks that seem small. Researchers at UC Berkeley decided that these abilities could be useful for search and rescue missions, so they built a palm-sized robot with a jointed plastic shell, CRAM, that could do exactly what the cockroaches do. This robot is made of poster board and polyester, which was built with highly compressible and bendable legs mechanized for speed. The speed correlates with the uniqueness of their bellies and legs. Scientific trials show that this allows for quick movement by modifying their size and shape and regaining it back according to their environment. This movement is called body friction legged crawling. It also has a plastic shield that imitates the insect's wings and the malleable outer layer that covers its entire body. CRAM was created to perform in both open and confined spaces. Number 6. Snake robot. Search and rescue missions are a common theme for animal-inspired robots. The robot snake design provides a small diameter and has the ability to move in almost any direction. This makes the robot ideal for accessing tight spaces. The robot is designed to move like a biological snake and has the potential of meeting the growing need for robotic mobility in unknown and challenging environments. They use their internal degree of freedom to maneuver tightly packed volumes, accessing locations that people and machines cannot access. The robot has 12 segments, actuated by servo motors and joined with metal brackets. The servo motors are controlled by an Arduino Mega and powered by a 7.4-volt battery pack. It also has a camera on the front and can be remotely controlled. Make sure to subscribe to this channel and give this video a like if you are loving the content. Number 5. Biohybrid Stingray. The Biohybrid Stingray is built out of silicone and rat heart muscle cells, making it a biohybrid machine. That is, it is part robot and part biological tissue. Its size is just like that of an average coin. The rat heart cells grow on a silicone mold fitted over a 3D printed gold skeleton. This robot moves using a technique called optogenetics. When the heart cells hit a beam of light, they contract. Just like the ray does, this robot uses the same synchronized undulations along the edge of its fins to propel itself, While a ray has two sets of muscles that pull the fins up and down, the robot has only one. It moves in only one direction, and the gold skeleton counters them like a spring. The muscle cells are also genetically modified to be activated by flashes of light. Number 4. Batbot. A batbot is a robot that mimics the movement of a bat. It is as heavy as 2 golf balls. They have soft wings, so the potential for injury is less. Their skeleton is made from carbon fiber and 3D printed ball and socket joints, which are covered by a soft, durable silicone membrane. The membrane allows the robot to change the shape of the wing structure during flight and is capable of autonomous flapping flight. It also conserves the power supplied by the micromotors on its back by generating lift as the wings flap. Batbot does not have quite as many joints as a real bat. It has just 9, 5 active and 5 passive joints. Number 3. Salto. Salto stands for saltatorial locomotion on terrain obstacles. It was designed to mimic saltatorial jumping animals, like bush babies and kangaroos. Although it looks small, the robot has a mighty spring and step. It uses rotor-based thrusters and a system of linkages and gears to do its trick. Salto can spring over 3 times its height in a single bound. The ability to bounce and jump through obstacle courses makes it useful as a search and rescue robot. Salto can be powered by radio control. While in the air, it stabilizes and reorients itself using a rotating inertial tail and 2 little thrusters. The robot then launches in a different direction by spinning its tail one way. Number 2. Pleurobot. Pleurobot is a salamander-like robot. Swiss Federal Institute of Technology spent years trying to make sure that the way Pleurobot moves is as close as possible to the way a real salamander moves. The designers used X-ray videos to study how the amphibians move before building a true-to-life robotic version. They combined high speed, optimization, cineradiography, dynamic scaling, 3-dimensional printing, and high-end servo motors to allow their robot to accurately capture the degrees of freedom, range of motion, and gait behaviors of the real animal. It has a salamander's articulated vertebrae, which allows it easily to traverse tough terrain without losing balance, and also swim. It has a waterproof exterior and body parts. All this, combined with a sophisticated neural network, means this slithering amphibian is a great candidate for supporting search and rescue missions. Pleurobot has its own Twitter account. And number 1. Eelume. Eelume is an autonomous underwater vehicle created in Norway. It is an effective solution for conducting a subsea inspection, repairs, and maintenance. Its slender body and self-propelled arms allow for precise hovering and maneuvering even in strong ocean currents. One end of the arm can grab hold to fix vehicles, while the other hand carries out inspection and intervention tasks. One end can also provide a perspective camera view of a tool operation carried out at the other end. It can transit over long distances and carry out light inspection, repair jobs, and maintenance in the confined spaces that are not accessible by conventional underwater vehicles. The vehicle's name was chosen because of its eel-like elongated and slender body.